In this lesson, we will look at the basic trigonometric ratios of the angles inside of a right triangle. And those are the sine ratios, the cosine ratios, and the tangent ratio. To begin with, what we will look at is the labeling of a triangle. And when we label a triangle using the corners, then we use letters in an alphabet that follow each other, and we kind of label them clockwise. So as we start with one letter here, we would label the next corner as B and the next corner as C. And the sides that are opposite of this vertex, this corner, they would be called lowercase b, lowercase a for this side here, and opposite of this one would be lowercase c. And the same thing happens for PQR. Again, wherever you start, if you start here, then the next one would be right there, and the next corner would be right there. And this would be called lowercase p, this would be called lowercase q, and this side would be called lowercase r, always opposite of the corner that is labeled with the same letter. Now, to be able to look at the different trigonometric ratios, what we will do is we will identify what these sides are first. If we take a triangle and we choose one of the angles to work with, then we have three sides here that we will be labeling. One of those sides is called the hypotenuse, another side is called the opposite side, and another side is called the adjacent side. And so we will define what these are, and then we will look at the example of one of these triangles here. So the hypotenuse is the side that is across the 90-degree angle. That's the first one that you should be identifying always. And then we have the opposite side, which is the side that is across the angle that you work with. And the adjacent side is the one that is attached to the angle that you work with. So let us say, for example, that you are working with this angle right here, and let's call that angle theta. And you will start hearing many of the Greek letters with angles, and theta is one of those. So let's say I work with this angle theta. Now, the hypotenuse is always the first side that you should identify, and that is the one that is opposite of the right angle. So this here is called the hypotenuse, which you should know from the Pythagorean theorem already. And then we have the opposite side. Now, the opposite side is always across the angle that you're working with. So if I work with this angle here, then this would be called the opposite side. OPP for opposite. And the adjacent is the side that is attached to the angle that I'm working with. And since I want to work with this angle, then this would be called the adjacent side. Now, the hypotenuse is always the hypotenuse, but the opposite side and the adjacent side depends on the angle that you're working with. So for example, if I wanted to work, instead of working with this angle, if I wanted to work with this angle, and let's call it alpha, then again, this would be the hypotenuse, because the hypotenuse is always across the 90-degree angle. But I would now label this as my opposite side, and I would label this as my adjacent side. And so every time you start working with a right triangle and you want to use the trigonometric ratios, your first thing is to identify what is the hypotenuse, and then identify the other two sides based on the angle that you're working with. And now here are the ratios. When I take the opposite side and I divide it by the hypotenuse, let's go with a left triangle here. If I take the opposite and I divide it by the hypotenuse, I get some kind of a ratio. And to make this a little bit easier, let's say that this side is 3 something long, and let's say that this side is 4 units long, and this side here is 5 units long. So what I now know, by the way, to be able to actually get the hypotenuse, I would have to use the Pythagorean theorem. And just to show you that this is an actual triangle that you can get, 3 squared plus 4 squared is equal to 25. And if I take the square root of that, that gives me the hypotenuse, 5. So 3, 4, and 5. If I take now the opposite side of this angle, say 4, and I divide it by the hypotenuse, say 5, then my answer, my ratio is 0.8. My ratio between the opposite and the hypotenuse is 0.8. Now in the past, students would have had to take this number and convert it into an angle in their head using the unit circle, what is called a unit circle. Now we will not do that. We will use our calculator to convert this ratio into an angle. So our calculator needs to know that this is a sine ratio, and it wants to convert it into an angle. How do I convert that? By using the inverse sine ratio, which gets me from the ratio to an angle. So what I will do is I will use, if you can look at your calculator, you will see these 3 buttons here, but you will also see the inverse buttons just on top of them. So this will change your angle into a ratio, whereas this will change your ratio into an angle. And so here's what you want to do to figure out the angle for the ratio of 0.8. That is 53.130. So again, I'll just write it here as a reference. The angle theta is 53.1301. So here's what we did is we figured out the ratio, and that is 0.8. But to find out what the angle is, I have to go from the ratio to an angle, which means I need to tell my calculator that this was a sine ratio, and I want it now to find my angle from it, which means I am using the inverse sine button to figure out what the angle is from the ratio 0.8. If I take this number now and I say, this is my angle, and I want to find out what is this ratio equal to, then I will go from an angle to the ratio, which means I need to figure out, okay, I have the angle, and the sine of that angle will get me to the ratio, which means I need to use this angle and the sine button to figure out what the ratio is, and there it is. And so that's how you go from a ratio to an angle, by using the inverse sine. And to get from the angle to the ratio, you will need to use the sine button. So the sine button will get you to the ratio, and the inverse sine button will get you to the angle. Now, this conversion here tells the calculator again that you have the opposite side divided by the hypotenuse. You could also use the adjacent side divided by the hypotenuse, and in our case that would be 3 divided by 5. So let's try that. That's 3 divided by 5, and that gives me 0.6. So 0.6, that's my ratio. Now, to figure out what the angle is, I have to use not this inverse sine, but the inverse cos. And why? Because I use the adjacent to the, and the hypotenuse. So my calculator needs to know, again, which numbers did you use? Which sides did you use? And I used the adjacent and divided it by the hypotenuse. And so therefore I need to use the inverse cosine function to figure out what the angle is. And if you do that on your calculator, you can see that it is 53.13 and so on. And you probably have already tried this right now. If you were not writing, you probably have tried to go again from the angle to the ratio, to the cosine ratio, which uses the adjacent side, by pressing the cos button. So if I take this number and I press the cos button, then I will go back to my ratio. And that's the second ratio. So the first ratio compares the opposite side to the hypotenuse, and the second ratio compares the adjacent to the hypotenuse. Now the third ratio compares the opposite to the adjacent. And if I go back to my question here, to my triangle, here's what I have. I have the opposite from this angle. The opposite is 4, and the adjacent is 3. So if I take 4 and divide it by 3, then I get that ratio. 4 divided by 3 will give me 1.3 repeating. Now, to figure out what that angle is, and I hope you should realize by now that you will get the same angle. It's just you're using different sides with different conversions. And so the angle, to find out what the angle is, I will need to use the inverse tan conversion. And if I do that, I will use now 1.3333 instead of 1.3 repeating, just to show you that it'll be a little bit different in your answer. So I will use the inverse tan conversion, and that gives me 53.1294. So the angle is 53.1294, and you can see that that is a little bit different than the other answers that we've had. And that's why it is very important to always use 4 decimal places, because your conversion is very specific when you go from an angle or from the ratio to an angle. And again, you can take this number and you can convert it back into the ratio by using the tan function. So if I take this number and press the tan function, I will get back to 1.3333. And so that is how you use the sine and the cosine and the tangent functions, or the ratios, to figure out your angles, as well as figuring out what your ratios are. So sometimes your numbers are given to you, and then you can figure out the ratio, and then you can go towards the angle. But sometimes your numbers are not given to you, but your angle is given to you. And if your angle is given to you, then you can figure out the ratio, and using that ratio you can figure out one of the sides, the missing side. And that's what we want to do in this unit. First, we want to become comfortable with just general triangles, and then secondly, we want to become comfortable with using this in context. Before we move on, I just want to point out a few things about right triangles. First of all is that you can use the Pythagorean theorem. If you have 2 sides given to you and you're missing one side, you can always use the Pythagorean theorem, a squared plus b squared is equal to c squared. If you have 2 sides given to you and you want to find an angle, then you need to use one of these ratios. If you have an angle and another angle given to you and you're trying to find the third angle, so the 90 degree will always be given to you, because these ratios only work on right triangles. So if you're looking for the third angle and you already have two angles, then you need to remember that all angles inside of a triangle have to add up to 180 degrees. So let us go into some examples on the next page.